But you know, there have been new developments, even in this mundane field of study, the physics of motion, and I can illustrate that with another ball that swings back and forth. And this is a tennis ball, very much like the bowling ball pendulum was. And it swings in a very regular and repeatable manner. You can see it on the television monitors. But I can modify this experiment in one slight way. There's some blue things here, and I can move those over underneath the tennis ball, and I can start it again. And the first few times it swings over those blue things, you see it looks about the same, but after time goes on, you see the motion becomes very much more complicated. And you may have guessed those blue things are magnets, and there's a magnet in the tennis ball, and 2 of them are attracting the tennis ball, and 2 of them are repelling it, and so the tennis ball sort of doesn't know what to do, you might say. And so even though we understand the laws of physics that govern the motion of the tennis ball, we understand magnetism and everything that's involved, we still can't predict where that tennis ball is going to end up. And that's pretty amazing. This is an example of something in science that is fundamentally unpredictable. And this is what we call chaotic motion. And it was discovered, or really rediscovered, only in the last 30 years or so. And it describes many different phenomena that we encounter in the everyday world. Here's another example of a chaotic pendulum. It's really 2 pendulums. If you look carefully, it's hinged on this side, but this side is rigid. And there are really 2 ways in which it can move. It can move with this more or less up and down, like that, or it can move with this stationary and that swinging back and forth. But if I start it up like this, you will notice a very complicated kind of motion. And that's an example of chaotic motion. And if we had 2 of these and we tried to start them exactly the same, the first couple of swings may look similar, but after a while they would be doing completely different things. And that's an example of something that's unpredictable, even though we understand the basic physics. Now, there are a lot of things in nature that are fundamentally chaotic. One of the first examples that was discovered was the weather. Way back in the 1960s, there was a meteorologist at MIT named Edward Lorenz. And on the crude computers of the day, he was making models of the weather. And one of the things he discovered was that if he restarted his model with a slightly different initial condition, that the prediction would be pretty good the next day, but 2 or 3 days later, the prediction would be terrible. And so he realized that long-term weather prediction is probably impossible, and probably will be impossible for the next millennium, because the atmosphere is a chaotic system. So we might be able to predict the weather 3 or 4 or even 5 days in advance, but probably not 2 weeks in advance for that reason. And he even gave this a nice name. He called this the butterfly effect, because he said it's as if a butterfly flapping its wings in Brazil could set off tornadoes in Texas. And that's literally possible for that to happen. And so since we can't know the state of every butterfly's wings, we really can't make long-term weather predictions that have any degree of accuracy.